Hi, thanks for having me here, and a great pleasure to be here and talk about the infrastructure and agents. I'm just going to run a very quick thought experiment with you. What if agents were human? And how does that help us think about the infrastructure? Try to. Wait. Okay, so over the past many years, human society has built a great amount of infrastructure that empower the human. So the question is, what can we build to also empower agents? This is interesting because AI agents and the human are somewhat similar but also different. They have digital neurons. They were trained with human-generated data. They are aligned with human instructions. However, they are machines. They can run much faster with higher precision, and also they can memorize a lot of things than we can. So the question is, what can we learn from the past experience of building those infrastructure for human, so to help us imagine a world of AI? I'm going to make a bunch of analogies here, but let me start from one of the most important infrastructure in our life, utilities, like water, electricity. So AI agents also need utility. Data is in the field, computer is in the electricity. We will build like data centers and power stations for sure, but at the same time, efficiency is very important. We want a power efficiency. It's always nice to have better flow per watt. And also there's a paradigm shift from just make compute more efficient to also make a data movement more efficient, as Bill mentioned earlier in the talk. And LLM in particular has long text window. You have to fetch data from different places, different memory hierarchies, different chips, sometimes even from disks. We also want operational efficiency. Cloud vendor like Lambda and Foundry, we work really hard to provide cost-effective cloud solutions, slice and dice resource for different use cases, training, inference, running agentic applications. We also want to embrace federating those resources across different regions, different clouds, and provide managed experience on top of Slurm Kubernetes, so to further improve the efficiency of using those compute. We also want data efficiency. We want all the data in the same place, ideally. We want cheap storage, fast query. We want running AI ML together with business intelligence. Also, we want to support the multimodal. Last but not least, we want model efficiency. We want to support people to build their own model with their own data. We want to use model routing to connect the right model with the right task and avoid wasting compute on basically overthinking on a simple problem. And also to call back what Bill said earlier, you want a small model to use tools instead of a huge model to do everything internally. Another very important infrastructure in our life is communication. Humans use communication to collaborate. I believe so do agent. And the good communication comes from good user experience. For example, humans need sub 200 millisecond latency to have a good interactive experience. And we sort of lose our attention if we have to wait for more than a few seconds. And we are not very good with multitask. We just like, it's very expensive for us to do a context switch. On the other hand, there are a lot of web servers that are non-human facing already running at a much lower latency. And the agents are great with multitasking. They can run many jobs in parallel or synchronously. So sometimes you can argue maybe time to last token is more important than time to first token. Agent can also process a lot of information in one session. So high memory capacity and bandwidth is going to be super helpful here. We also want a good user interface. Currently, natural language is being used as the first-class interface to connect an agent with different tools. But down the road, when agents step into a real world, they have to see, to hear, to sense in order to take actions. So true multimodal MCP is going to be crucially important here on the protocol level. Our society also has a strong foundation to educate, recruit, and grow workforce. The same thing can be imagined for agent. We need a platform to train, eval, and improve them. Now, I would argue that eval is probably one of the most challenging and underrated steps in this process. Just imagine how much work you would put into recruiting the right people for your team and find your ideal partner for your startup. This is the sort of effort you want to put into eval your agent. At the same time, static leaderboard eval is kind of useful in the sense that they are guardrails and lighthouse, but lighthouse is not where our destination is. We want to accomplish a real-world project, so it's important to embody those evaluation into your project and see where the gap is and try to close that gap. There's performance, there's also cultural fitness and compliance. It's been noticed that integrating agent in a vibe setting is easier. A lot of enterprise-level adaptation for vibe coding, vibe research is already happening. But on the other hand, once you incorporate agent into your core business, once they start to touch your business data, internal tools, and generate external-facing service that run at the stake, there's a lot of security, safety, and other compliance kick in, making things harder. We can keep imagining what would be a good health system for agent, what would be a good finance system for agent. Currently, token is used as a currency for AI, but that currency has been deflating quite a lot over the past years. So what's the implication of that to the sustainability of AI system? If a token is a currency, who are the banks and who should play the role of Fed? Human can also generate token. Can we pay agent by human feedback? If that's the case, what's the exchange rate between human token and agent token? I just want to finish the talk by saying I'm really, really impressed by the self-driving drive cars on the street in San Francisco. To me, we can learn a lot from how people build them and deploy them. They are, in essence, agents that integrate smoothly into our life. We didn't really change anything on the street for them. They just fit in. Or should we change something for them? What would the street look like if all the cars become self-driving cars? And I'll leave that for your own imagination. Thanks.